All right, so a little intro into electromagnetic radiation. And so the kind of basic thing is the relationship between wavelength, amplitude, and frequency. The standard kind of measures that we have for waves. And the big idea in electromagnetic is that wavelength and frequency, the product of those two are always equal to the speed of light. And so it doesn't matter where you are on the spectrum for the different waves. And so here it shows you then C equals wavelength times frequency, and those units then will scale accordingly. The other kind of aspect of it is that we focus on the visible range because that's what our eyes actually detect and everything. And so I like for my students to kind of just know the limits. Violet is at one end, 400 nanometers. Red is at the other end, 700 or 800 nanometers. And and so then on the overall spectrum, gamma is the highest energy and radio is the lowest. And so it's just start there and then add levels of detail as you go. So in the sim calculations that you're going to have is going to have that relationship between speed and frequency and wavelength and frequency to do those relationships. And the other one, unfortunately, it doesn't put it here, but E equals H nu, Planck's constant. So that's the other thing is that once you get that relationship to actually go to the energy, we use frequency. And so it's a simple calculation and spits out joules. And again, frequency kind of doesn't match. Most people know wavelength, and so you have this kind of inverse relationship with frequency. And so the shorter the wavelength, the higher the energy. And so those are the types of problems that you'll have in that simulation.